Hello friends, welcome to Electrical Design Engineering YouTube channel. Today is our 14th lecture of our free course Design of Transmission Lines and Distribution Lines. Before starting today's lecture, please subscribe the channel, like and share videos on your social media profiles. The topics covered in previous lectures are available on my YouTube channel. I can show you my YouTube channel here. This is my YouTube channel, and here in the playlist you can see there is a separate playlist on design of transmission lines and distribution lines. On clicking on this playlist, you will find all the previous lectures. There are other playlists also available, like selection of cable sizing and voltage drop, short circuit analysis, electrical engineering interview questions. These all playlists are also available here. You can watch all these playlists free of cost. Now we will start today's lecture. In today's lecture, we will solve this example to understand what are the steps and how to calculate earth resistance of an electrode. The example is: calculate earth resistance of a rod having diameter 12.2 mm and length 4 meter. The soil resistivity is 500 ohm meter. The system has a fault current of 10.35 kiloamperes for 1 second. You should note down some details: diameter of a rod, that is 12.2 mm, length of the rod, that is 4 meter, and resistivity of the soil, that is 400 ohm meter, and the fault current, that is 10.35 kiloamperes for 1 second. You can note down these things in a rough way because you need this data. Step first, calculate maximum allowable current density of GI rod as per IS 3043. The formula for that is I equals 7.57 into 1000 divided by square root of rho into T, where rho is the resistivity of soil in ohm meter, T is the duration of fault current in seconds. Putting the value of rho, that is 500 ohm, that is the resistivity of the soil, and T, that is the duration of fault current, which is 1 second. In this equation you will find the value of I. I equals 7.57 into 1000 divided by under root of 500 into 1. On solving, it becomes 338.54 amperes per meter square. Step second, calculate curved surface area of a rod. The formula for that is A equals 2 pi or L, where L is the length of rod in meters, that is 4 meters, and R is the radius of the rod, that is 0.006 meters. Putting these values, we get A equals 2 into 3.14 into 0.0061 into 4, that is 0.153 meters square. This is the curved surface area for the rod. Step 3, calculate maximum current dissipated by one earthing rod. The formula for that is ID, that is the maximum current dissipated, is equal to current density into curved surface area. We have already calculated the current density and curved surface area of a rod. Putting these values in this equation, we can get the value of ID. ID equals 338.54, that is the current density of the earthing rod, into 0.153, that is the curved surface area of the rod. It becomes 51.8 amperes. Step 4, calculate number of electrodes needed. Now we have to calculate the number of electrodes needed to bear the fault current, that is 10.35 kiloamperes for 1 second. The formula for that is N equals fault current divided by current dissipated by one electrode. N equals 10350 amperes, that is the we have converted the kiloamperes into amperes, divided by current dissipated, which I already calculated, is 51.8. It becomes 199.80, that is approximately 200 number of earthing rods are needed to for this fault current. Step 5. Calculate earth resistance of a rod. Isolated rod, we have to calculate the earth resistance of one rod. R equal Re, that is the earth resistance of a rod, equals rho divided by 2 pi into log of E 8L divided by D minus 1. This I have teached this formula in my previous lecture, where rho is the resistivity of soil in ohm meters, D is the diameter of a pipe or a rod in meters, and L is the length of a line in meters. Then length of the rod. Sorry, L is the length of the rod. It is not line, it's length of the rod. Putting these values in this equation, we will get the Re, that is the resistance of a rod. Re equals 500 divided by 2 into 3.14 into 4 into log of 8 into 4 divided by 0.0122 minus 1 equals 136.78 ohm. This is the resistance of a rod, isolated rod, one rod. Step 6. Select the configuration of earthing rod. There are different configurations. Either you can connect these 200 rods in a one line, in parallel in a one line, or you can make a hollow square and connect these 200 earthing rods. For that you had there is a factor lambda for different configurations. I will show that you. For parallel electrodes in line, as per the BS 7430, the value of the factor, the value of the lambda is given here in the table. For 10 number of rods, 10 number of earthing rods connected in a row, the lambda value is 3.8. For 10 or above 10, if you have a 20, 200, 300, then you have to take the value of lambda 3.8. For below 10, there are different values given here in the table. You can select the table value of lambda accordingly. Another configuration is this is the hollow square configuration arrangement. Same, there is also given here the value of lambda for all number of electrodes. Here is the number of electrodes and this is the value of the lambda. This is as per the BSc 7430. If you have more than, here we have a 200 electrode, 200 number of rods, 200 number of electrodes. So here we can take 9.4. The maximum value of lambda, that is 9.4 for 20 or above 20. Step 6. Calculate total resistance of a group of electrodes. The formula for that is Ra is equal to Re 1 plus lambda of 8 divided by N. Here the value of lambda you can get from the table, and Re which we have already calculated, and we have already calculated. Now there remains A. We have to calculate first the value of A. The formula for calculating the value of A is A equals rho divided by 2 pi Res, where R is the resistance of a single rod, which we have already calculated, 136 point something 74, and S is the distance between adjacent rods, let it be 4 meters. Rho is the resistivity of soil in meters, that is 500, and lambda from table you have to take the value from table. Putting the value of Re and S in equation 2, and we will get the value of A. A equals 500 divided by 2 into 2, 3.14 into 136.78 into 4, that is 0.14. Putting this value of A in the equation first, Ra equals 136.78 into 1 plus lambda the has taken from the table 9.4 into, and this is the value of A 0.145 divided by 200, that is the value of N. It becomes 1.62 ohm. Now the resistance of 200 earthing electrodes is, when they are connected in a hollow square configuration, is 1.62. Step 7. Suppose these rods are connected to each other by a GI strip of width 12 mm, length 800 meters, buried in a ground at a depth of 200 meters. These rods are connected to each other by a strip having these dimensions, and the strip is buried 200 mm from the ground level, from a finishing ground level. Now we will first calculate the resistance of the strip. The formula for that is Rs is equal to 100 rho divided by 2 pi L into log of 2 L square divided by Wt, where rho is the resistivity of soil in ohm meters, that is 500 ohm meter. W is the width of the strip in centimeters, that is 1.2 centimeters. We have given that 12.2 mm. We have converted mm into centimeters here. D is the depth in ground in centimeters. We have given here the 200 mm, 200 mm depth, and we have converted it into centimeters, that is 20 centimeters. L is the length of strip in centimeters, that is 8000 centimeters. Putting these values in this equation, you will get the value of Rs. Rs is equal to 500 divided by 2 pi into 80,000 into log of 2 into 80,000 square divided by 1.2 into 2 20, it becomes 2 ohm. This is the resistance of the strip only. This is not the whole resistance of the earthing, this configuration of the earthing. This is the resistance of only strip. Step 7, sorry, this is step 8 actually. Now we will calculate the total resistance of this whole earthing system, including the strip, including the rods. For that, that is the net resistance is Rn is equal to Ra into Rs divided by Ra plus Rs. The value of Ra is 1.62 and the Rs is 2 divided by 1.6 into 62 plus 2, that is 0.889 ohm. This is the resistance of the whole earthing structure. You can say earthing mat or a mesh. Whole earthing structure, the net resistance is 0.8 ohm. Now if you want to check whether the earth resistance of an earthing electrode is same what we have calculated or not, for that we can use the earth resistance tester. The earth resistance have 4 terminals. These are the 4 terminals of the earth resistance, and we can use this is the earthing electrode for which we have to find the resistance, and these are the 2 spikes. If the distance between earthing electrode and the outer spike is d, then the distance between earthing electrode and the middle spike should be 62% of the d. First we can short circuit the P1 and E1, then connect the E1 to the earthing electrode, then connect to P1, P2 to the middle and E to the lasting outer electrode, and press the test button on the earth resistance resistor tester, and you will get the value of earthing resistance of the earthing electrode. Thank you.